Good afternoon, ladies and gentlemen. After two long presentations, people tend to sleep at the back. If they can wake up, please. I won't take long. I will not stand between you and a cup of tea outside. So I'll be quick and focused. I represent Ansari Precision Instruments, a company offshoot of an old BAA and Sons started in 1936 by my grandfather. So by default, a third generation entrepreneur, and expanded into 7 different companies, creating a group of industries, touching into various verticals, but primarily an instrumentation company. We started our career from a place called Roorkee, about 170 odd kilometers north of Delhi, in the state called Uttarakhand. And we started with the repairing of the Ganges Canal equipments that were imported by the Stanley London company from England in those days. And my grandfather came out and started with the factory manufacturing or replicating those instruments, traditional, which till today we are manufacturing and selling to, exporting it to third world countries for Ministry of Education, polytechnics, vocational colleges, etc. Starting from a hand level to a dumpy level, and from a vernier theodolite to an optical theodolite, and things like that. But over the years, the face of Ansari's has changed. We have partnered with a few companies from overseas for their various modern surveying systems. Like we are representing an Italian company called Stonex for its modern surveying systems, short-range scanners in Lidar from 300 meters range, GNSS, and total stations, and other accessories for surveying. We are also representing for last 20 years a company based in France for their permanent intelligence survey markers. This is a typical mechanical survey marker instead of the concrete pillar used by Government of India and other places. The most successful case was done in the country of Bhutan, where we planted more than 600,000 markers, and in the state of Punjab and in the state of Haryana later on for land records development program. The marker can be embedded with an intelligent chip inside, which works on an RFID technology, and which can give you the coordinates of the place. You can have it written, and you can have that information inside. A very good tool for GIS development. We are also partnered with the father of LiDAR or mother of LiDAR, whatever you call it, a company called Optech, Teledyne Optech now it is, and the world's inventors of LiDAR, the company which has their LiDAR even on the Pathfinder in Mars. So we represent them in India for their terrestrial, mobile, and cavity scanners. I'll touch on that later on shortly. We also represent a company called Planix. Now that is a name which doesn't ring any bell anymore in Indian surveying fraternity, because people know more of LiDAR and they don't know the heart of LiDAR. Shortly, it was discussed by Richard in his presentation as an IMU and INS, and a positioning system. I'll touch on that as well. We are widely spread in India, and almost every branch office of mine is equipped with modern testing facilities and repairing facilities for the modern optomechanical and optoelectronic systems, which we can do. We have factory-trained engineers from overseas who are capable of handling any kind of instrument. Okay, the topic for the day, I'm making it quick so that your taste bud doesn't die off and you have your tea fast. 3D lidar data acquisition techniques. We have been discussing that since morning. I will be very quick, and I will not read out anything on the slide, so you may please do the honors. A whole load of areas where we can use this very fascinating technology. And we have many challenges in the urban scenarios, in the terrains where just Mr. Gaurav was mentioning. And you have obstructions, you have a lot of limitations in terms of the terrain itself, in terms of the buildings around, or the vegetation around, or whatever. This is a beautiful technology. Having said that, how does it reply to all these applications? And how does answer to various challenges that the surveyor faces in the field? Starting from a terrestrial scanner, which is a tripod-mounted scanner, and of course, a mobile scanner, which is a vehicle-mounted scanner. I'm talking in a layman's language. Please excuse me, because I'm a traditional surveyor, 25 years old in this field, and I have started my life with chain and tapes, and so please excuse me for that. Anyway, the technology evolved from a mobile mapping system of a mapping grade to a survey grade, and then to an engineering grade. I'll tell you the differentiation as well. One of my earlier presenter, I think from CCON, mentioned of something on a pushcart. Yes, we do have a technology available on a pushcart where a guy can carry it inside an airport building or inside a big industrial setup and scan the whole place. Yes, of course, we also have airborne scanners. That is one of the major strengths of Optech globally, and they have been market leaders in the airborne scanning system. Different options. And of course, different scanners, different cameras, different sensors, all put in together on the aircraft, and we go for the flight. Something which is rarely seen in India with so many bureaucratic tiers. You don't get clearances, so this becomes a dream. Anyway, we're looking forward that one day the government will wake up to this technology and will allow this to happen. Likewise, the UAV, the sensor mounted on an unmanned UAV or a copter, microcopter, so we have a sensor available for that as well. A backpack, a solution which we have made based on the Faro scanner, essentially. And you can use it on a backpack, but this also has an IMU inside. Let's see what is a Lidar. Now, we have been talking about Lidar. Most of the people probably know what a Lidar is, and there was few slides I've seen from previous presenters that how the technology works. Time of flight, yes, that is how it works. You send a pulse, it touches the surface, the clock starts ticking. The reflectance come back, some of them haywire and some of them directly received, and the measurement is done. So this is what is basically Lidar. Now, what is the difference between that? The only difference is that in a total station, you collect 1 point, one shot, and in a scanner, you coat the whole surface. You have multiple points. You have millions and millions of points. So that increases your trouble back office because you have a lot of data to treat later on. What are the actual essence of a Lidar? One is range, of course, the distance between you and the object. The other is the efficiency of the scanner. And a very important thing is the step size, the difference between the two spots of the laser, because that is what will form a grid on the surface that you are measuring. So that step size is the key for any scanner. Now that most of the scanner companies will not tell you, I'm telling you, because I'm one of the best step size representing Optech in this particular field. We have been talking a lot about IMU or INS, Inertial Navigation System. Well, yes, this is the heart of any mobile mapping system, be it based on the camera, be it based on the Lidar. Without this, you cannot have an exact positioning of your vehicle, where it is and how it is working. What does it do? It has, yes, it has a gyro inside, it has a lot of accelerometers, it has a lot of measurements which it does, starting from your positioning, your velocity, your acceleration, orientation, all these different kinds of parameters is what is done by the IMU. The velocity measurements, I'll quickly run through it. I think Richard has already explained this. Whatever the heading, pitch, roll, it all takes care of it on the road. So I'll go through it. How does it work? just a short video, if I can make it run. You have the network of satellite around the globe. You can call it Navstar, or you can call it anything, and you get connected with a receiver that is in your vehicle, and you look for your position. So the receiver receives when you are in the vehicle, and it tracks a couple of, probably 6 of satellites, gives you the location and the positioning on the globe where you are. What happens when it runs into a very heavy canopy of tree cover or a concrete cover, or it goes inside the tunnel? Deadlock. You don't have any connection to the satellite, so a Planix, that is the heart of the instrument that I have told you, kickstarts. And it maintains the trajectory all the way till it again gets connected to the satellite and, make your life very smooth and very accurate. This was all about Planix. That is a Trimble company, of course, but we represent that exclusively in India as well, because we are providing a complete solution to mobile scanning. Terrestrial scanners, well, I'll run through them very quickly, what they can do, what they cannot do. We have scanners starting from a short range of about 1.7 kilometers, and it can go up to 3 kilometers. We have high-resolution scanners. We have high-definition scanners. Now, why are all these required, the high-definition, high-resolution things? Now, accuracy was one thing which was mentioned earlier in one of the presenters. There is one thing which is known as a relative accuracy. There is another thing which is known as the absolute accuracy. So we'll talk about that in the later part of the slide. This yellow box, grandmother's television set, which you can see on the screen, still alive and kicking, and this is still was sent to the Mars on the Pathfinder. One of the technology which is recognized by globally by researchers, by institutes, by colleges, and anyone and everyone who's really, really interested into accuracy and doesn't go on the cosmetic look of it. The long range and the short range scanners, probably the one used in the Costa Concordia, the disaster management, one of the application of the scanner, which was mentioned by Mr. Jairam, I think, from CCON, the Lidar uses. The another disaster can be the slope monitoring, which is happening very fast and very quickly in my state. Yes, there was a disaster 2 years back in Uttarakhand. So this is what we can remotely monitor. We can put up the scanner. It is an IP67 rated, so it's military grade. You can set it on a certain threshold, and if the slope starts moving, it triggers an alarm, or it sends you a text, or it sends you a mail, and it can give you that precious little time to move the people from that area. So yes, it can be used in disaster management as well. Civil engineering, that is one area it's very commonly used, the terrestrial scanner as well as the mobile scanner. There are only few slides. I'm running through it, what it can do. Mind you, this is not a picture. This is all point clouds. I'm not showing you any picture. Well, this was a picture. And you can have a geology and other hazards also mapped, scanned, and measured. One of the essential use of the terrestrial scanner, for which this scanner was actually invented, is for mines and open pit mines. And what it does, maybe I can show you a small little clip here. It makes your life very easy, because what you're doing with the total station is collecting one point every time. This is collecting millions of points. So imagine in 1 square meter, total station will give you 1 point, and this instrument will give you 150 points. So the kind of information that you are getting for that particular patch is huge, immense. You can slice through anywhere, and you will have a point, so you'll have a reference. When I say point, it's a georeference point, because you have a base station based on which you have georeferenced your system. So each and every point is a georeference point cloud. So you can zoom in, click on any point, and you will have a measurement there, X, Y, and Z. Mobile lidar, Optech has 2 categories of mobile lidar. One is the mapping grade, which is about less than 5 centimeters accuracy. And the other one is a survey grade, which is 1 centimeter accuracy. Survey grade has two sensors head, which spins on an x-axis, and it gives you a coverage of about 250 meters of the corridor, and it scans. It does have a Ladybug camera, which is a 360-degree panoramic camera on the top. Of course, with a GPS, an IMU, and a heading GPS, all of them clubbed together in one particular vehicle. But you will be amazed to see the size. The box is only this big, and the entire technology is there. Very handy. Single guy can lift it, carry it, put it, and start working. Some advantages, and I think most of it has been mentioned before me. Applications, of course, survey grade and mapping grade is what I have already mentioned, about 1 centimeter accuracy or about less than 5 centimeter accuracy. There is one more interesting LiDAR, which has not been mentioned anywhere in the survey conference or anything that we have, is a engineering grade LiDAR. This LiDAR is researched and developed by Fraunhofer Research Institute in Germany. And this is the only one of its kind equipment in the world, totally eye-safe. It delivers an accuracy of 0.03 millimeters. So what Richard is doing with a single line laser, we are doing it with a scanner. Of course, it is mounted on the same height of about 3.5 meters, and it has a swath of about 4 meters, and it focuses down on the pavement, and it gives you a very, very accurate pavement surface conditions. You can monitor the crack. Imagine 0.03 millimeters. So we are not doing any triangulation here. This is a direct scanning and direct readout of the pavement condition. We also have another excellent scanner coming up from the same Fraunhofer Research Institute, which is a 360-degree rotating scanner, and it gives an accuracy of roughly about 5 to 7 millimeters. Amazing. Now this is what a technology has taken over from all these LiDARs that we have been talking about since morning. One of the best. So you don't need a total station. I have done a test with Ministry of Road Transport and Highway, and based on their levels of digital level, whatever they have given me, the Z levels of the entire corridor of that patch that they gave me to survey, and we matched it. We matched it totally with our scanner. That is an amazing technology. I'll show you some of the utility locations, the asset inventory that you can do with this kind of technology, highways, roadways, beach projects, bridges. I'll just go quickly. A flood simulation is another thing that you can build up. You can build up a lot of simulations based on this technology, and the software is available for various GIS applications. Of course, it can be used for the as-built survey, like the other gentleman was telling, for BIM modeling, another aspect. Finally, the final output, the dream project of our Prime Minister, Honorable Prime Minister, Mr. Modi, a smart city. Now, his dream is what we have implemented like this, actually. Everything mapped by a survey-grade LiDAR on a vehicle. You can have various feature extraction. Now, that is what I love about LiDAR technology. You know, I love the word saying scan in the can. You scan the whole thing and you put it in the can. Now, today you are scanning it for the roads, but tomorrow you may need it for the high-tension wires. You may need it for the lamppost. You may need it for any asset on the road. So what you just have to do is you bring it out from the can, you extract that particular portion of data and give it to the customer. So scan in the can, that is my keyword, and that is what I keep on saying, that this is the most beautiful technology where you don't even have to actually go and pinpoint that particular measurement that I have to do. I'll have to do only for the, say, street lights or street lamps, or I have to do it for manholes. No. You scan and it doesn't understand anything. It just scans the whole surface. It paints the town totally. And this is the result. End of the day that you get. You can bring out anything that you need from the can and give it to the user. This will be probably a dream coming true in India, where you will have an information highway where you'll have a total GIS, multi-layered information system packed into one can. And that can probably would be somewhere in the PMO or wherever. And this will be used by various departments in India. All point clouds, no picture. Actually, pictures are used basically for the people who doesn't have that kind of LiDAR, which gives you an imagination of what you are seeing. The step size, that was what I was mentioning earlier, that if the step size is so dense, the point cloud is so dense, you don't need a picture for reference. You can actually see it and you can recognize what it is. You can extract the feature just like that. We have another technology which is for fusion for airborne bathymetry with the LiDAR system. Now this is something that we have been called by Government of India to look into the Adam's Foot or the Ram Setu, that bridge they intend to build between Sri Lanka and India, and use this technology there. This is one of the core competence of Optech in this particular area of airborne bathymetry, and they have been very successful. They have done a very big work in Philippines, a very good case study for disaster management, where they have built up using the same technology. These are few sites, I think, which can show you how it works. Optech is now Teledyne Optech. So Teledyne is the company, is a Fortune 500 company that has taken over Optech. So Teledyne also is producing Raison Seabath. I think one of the stall outside there I saw. So they market. So you can use these two technologies together to scan under the water, inside the surface, and above the water, if you mount it on a boat. So you can develop something like this. Imagine cleaning Ganga with this technology, how quick and how fast it can be. So you just have to put a LiDAR sensor on the top of the boat. So you have the entire topography and the side bumps of the river, and you have the siltation study. So you can actually tell how much silt has to be dredged and taken out. You can actually give the quantity so exactly that government of that particular state can earn money, can tender it out and earn money out of it. You know, it can be a self-reliant and profit-rich kind of a project. Some sample outputs of the river bank and all. As I have promised that I would be quick, so I think it was less than what, 12 minutes? Am I fine? Thank you so much for a patient hearing.